Hi, and welcome to this short clip going through a levelled question, typical OCR style, on rate determining step. So first of all, we'll use the rate data in the table to construct a rate equation. And we'll use this alongside the overall rate equation provided to allow us to propose a two-step mechanism. So first of all, let's have a look at the instructions. We need to determine a rate constant and a possible two-step mechanism for this reaction that's consistent with these results. And the response should clearly show how any calculations and explanations are linked to the experimental results that were given. So looking at the instructions, I can see that there's three things I've got to do. So the first thing to do is to work out the orders for everything, and then using those orders I can determine the rate constant, because it allows me to work out a rate equation. And the resulting rate equation will allow me to construct a mechanism. So if I look at experiments 2 and 3, I can see that the ozone concentration remains the same, but the NO2 concentration doubles. At the same time, the rate doubles, so therefore it's first order with respect to NO2. If I now shift up to experiment 1 and 2, where the concentration of nitrogen dioxide remains the same, the concentration of ozone trebles and the rate trebles, so therefore it's also first order with respect to O3. So that allows us to write a rate equation, which is K times the concentration of nitrogen dioxide times the concentration of ozone. So if I need to calculate K, I also need to calculate the units. So I need to assume that the units of rate are moles per decimeter to the minus 3 second to the minus 1. And each of my concentrations are moles per decimeter to the minus 3. So putting the numbers in, you get 0.0128. So I need to work out the units. So some cancelling has to be done. So that allows us to work out moles to the minus 1 decimeter cubed second to the minus 1 as our units. So now what we have to do is work out a possible mechanism. So now we've worked out the rate equation, we can assume that both of those species are in the rate determining step in a 1-to-1 mole ratio. So the next thing to do is to think about relating this whole thing to the overall equation. We need to make something called N2O5, and unfortunately N2O5 can't be made by simply mixing NO2 and O3. That would give NO5, which isn't in the overall equation. But N2O5 is in the overall equation, which then allows us to put that in the fast step. Now we also need an intermediate to react with the second NO2 molecule from the overall equation in order to create our N2O5. So we could use NO3. Now I know NO3 doesn't sound like a likely species, but remember it's an intermediate, so it doesn't have to exist for very long. It can simply be created in one step and used up in the next. So if we cancel out NO3, which appears on both sides of the individual steps in the mechanism, so it's produced in the first slow step but then used up in the fast step, that leaves us with two NO2s, an O3, an N2O5 and an O2, which is the equation we were provided with at the start. Okay, so hopefully this has been a useful run through of how this type of question might be approached and how you might construct the mechanism. So for now, thanks for listening, and until next time, see you soon.